Finally, let's summarize our reactions of alkenes. At the start of this chapter, we saw that we can convert alkenes to alkanes, alcohols, diols, alkyl halides, dihalides, halohydrins, epoxides, and ketones or aldehydes. We're not looking at all of these. Some of these we'll see next semester, but let's talk about the ways to make these compounds. As we worked our way through the chapter, we focused on the different mechanisms, but now let's focus on the overall transformation. So from an alkene to an alkane, we need to carry out a reduction, and this is where we are going to use hydrogen and a catalyst such as palladium or platinum or nickel. Choose your favorite transition metal catalyst. And this is going to work to convert your alkene to an alkane. So we're adding HH across the double bond, and this proceeds with syn addition. To convert an alkene to an alcohol, well, this is where we have the most flexibility. One approach is to do acid catalyzed hydration, where we're adding water and acid, and this way gives us Markovnikov addition of the H and the OH across the double bond, and it proceeds through a carbocation. So we have to think about what that means in terms of the overall mechanism. A second approach is oxymercuration demercuration. So this is where we're adding in the first step mercury acetate with water and THF, followed by the second step of sodium borohydride reduction. Overall, this leads to Markovnikov addition of hydrogen and OH. There is no carbocation, so no carbocation rearrangement. And then finally, the third approach is to do hydroboration oxidation, where in the first step, the hydroboration step, we treat our alkene with BH3 and THF or B2H6, followed by the second step where we use hydrogen peroxide and hydroxide. And the net result is that we've added H and OH across the double bond, but it proceeds by non-Markovnikov addition, and it is syn addition of the hydrogen and the OH. Next, let's keep in mind the similarities and the differences if we want to convert an alkene to an alkyl halide or a dihalide or a halohydrin. So if we want to convert our alkene to an alkyl halide, we want to add hydrogen and a halogen across the double bond. So this means we are going to use HX. Similar to what happens with acid catalyzed hydration, the alkene grabs the proton, forming the more stable carbocation, and then the X- adds to the carbocation carbon. And so we have Markovnikov addition of H and X across the double bond. If we're trying to make a dihalide, now rather than using HX, we are going to use X2. Now, similar to the first part of this reaction, the alkene will share its electrons with one X, pushing away the other X, but then the first X shares back. So remember, this goes through the cyclic halonium ion intermediate. And then the second halogen adds to open up the cyclic halonium ion, giving us the dihalide, where the halogens are connected to adjacent carbons. Also, because of the cyclic halonium ion, what we have is anti-addition of the two halogens. And finally, in a related reaction, if we have our alkene and we treat it with X2 in the presence of water, the same thing happens where we get a cyclic halonium ion intermediate, but instead of the second X- adding, water is going to add as the nucleophile. So again, we have anti-addition, and our nucleophile adds to the more substituted carbon. We've talked about examples with water, but actually you could use other nucleophiles as well. Instead of water, what if you had methanol as your solvent? Well, you could add methanol. What if you had ethanol as your solvent? All right, so there's a lot of flexibility with this reaction. So at this point, you now have many, many tools in your synthetic toolbox. Not only do we have a number of reactions that we can carry out on alkenes, but remember, we've also learned a few methods to make alkenes. We can make an alkene from an alcohol, or we can make an alkene from an alkyl halide. We've also learned how to make alcohols from an alkene or from an alkyl halide. We've learned a couple different ways to make alkyl halides. So you now have enough tools in your synthetic toolbox to carry out multi-step synthesis.